Let us continue chemical equilibrium. Sums we will take chemical equilibrium sums we will take. First sum at 627 degrees Celsius at 627 degrees Celsius and 1 atmospheric pressure SO3 is partially dissociated into SO3 is partially dissociated into SO2 and O2. SO2 and O2. The density of equilibrium mixture is 0.925 gram per liter. What is the degree of dissociation? Okay. Now, here given is SO3 is undergoing dissociation. Density of equilibrium mixture is given. Now, degree of dissociation they are asking. Okay. So, how to do this one? We'll see. Now, we are taking what in the sense SO3 gas we are taking. It is dissociating to give what in the sense SO2 gas and half O2 gas. Initially, let us take 1 mole of SO3. 1 mole of SO3 we are taking. How much dissociating? In the sense alpha moles dissociating. How much at equilibrium in the sense 1 minus alpha moles. SO2 alpha moles produced, O2 alpha by 2 moles produced. Okay. Now what we have to find in the sense alpha we have to find using density of equilibrium mixture. Sorry. Now density of equilibrium mixture is given. Okay. We will take a ideal gas equation. PV is equal to nRT. This we will rewrite P is equal to mass by volume into RT by gram molecular mass. Like this we will take. This we will write it as P is equal to dRT by gram molecular mass. This D is called density. If you take this one in this place, then you are using this formula for equilibrium mixture. If you take 0.925 gram per liter here, that means the density of equilibrium mixture. That means you are using this for equilibrium mixture. So you are taking this is as a density of equilibrium mixture. This is as pressure of equilibrium mixture. This is as temperature of equilibrium mixture. Then we will get what in the sense gram molecular mass of equilibrium mixture. We will get it. Okay. So now we will substitute the values. Pressure of equilibrium mixture, we will take it as 1 atmosphere, pressure of equilibrium mixture. Then density of equilibrium mixture, we will take it as 0.925 gram per liter we will take. Okay. Then temperature we will substitute. Temperature is how much? R value we have to substitute temperature. Then gram molecular mass we will get it. Okay. So pressure of equilibrium mixture we are substituting, that is 1 atmosphere. Then density of equilibrium mixture we are substituting 0.925 gram per liter. 0.925 gram per liter. Then R value is 0.0821 liter atmosphere per Kelvin per mole. It is universal gas constant. It is constant value. Then temperature T is how much? Means 627 degrees Celsius. This convert into Kelvin. We have converted into Kelvin. Okay. Then in denominator, what is there? Means gram molecular mass is there. That is for what in the sense of equilibrium mixture. Gram molecular mass of equilibrium mixture. So from this we can get a gram molecular mass of equilibrium mixture. We will get what are the units getting cancelled, you see, and simplify how much we are getting in the sense gram molecular mass of equilibrium mixture. We are getting 68.35 units. We will see units cancellation. Will see here atmosphere cancel, this liter cancel, then per Kelvin cancel. So what we are getting in the sense gram per mole we are getting. So we got gram molecular mass of equilibrium mixture. We got it set. Now we will see the required thing what we want, in the sense we want alpha degree of dissociation we want. Sir, how to find degree of dissociation, that we will see now. This SO3 at equilibrium what and all is there, we know. We want this alpha only we want, therefore this we will consider. Okay, this we will consider at equilibrium, we will consider. So at equilibrium we will say mass of equilibrium mixture is equal to mass of SO3 at equilibrium plus mass of SO2 at equilibrium plus mass of O2 at equilibrium. Okay, this is at equilibrium we can say. So mass of equilibrium mixture equal to SO3 mass, SO2 mass, O2 mass sum, we can say. So mass of equilibrium mixture we can say number of moles of equilibrium mixture into gram molecular mass of equilibrium mixture, we can say. Number of moles of equilibrium mixture into gram molecular mass of equilibrium mixture is called mass of equilibrium mixture. Mass of SO3 we can say moles of SO3 into gram molecular mass of SO3 at equilibrium. Mass of SO2 will say moles of SO2 into gram molecular mass of SO2 at equilibrium. Mass of O2 will say moles of O2 into gram molecular mass of O2 at equilibrium. Everything at equilibrium. Now it is what, in the sense moles of equilibrium mixture. So moles of equilibrium mixture will see how much moles of equilibrium mixture. Now we want moles of equilibrium mixture we want. Moles of equilibrium mixture is how much, means SO3 1 minus alpha, SO2 alpha, O2 alpha by 2. Therefore 1 plus alpha by 2. 1 plus alpha by 2, it is a moles of equilibrium mixture. So that we will substitute. Moles of equilibrium mixture is 1 plus alpha by 2. Gram molecular mass of equilibrium mixture is 68.35 equal to moles of SO3 1 minus alpha at equilibrium. SO3 gram molecular mass, oxygen 48, sulfur is 32. So how much we are getting, in the sense 90 we are getting. That means SO2, this is oxygen is 48, SO2 is 32. Therefore we are getting 80 we are getting molecular mass of SO3. Moles of SO2 is alpha. Gram molecular mass of SO2 is 64. Moles of oxygen is alpha by 2. Gram molecular mass of oxygen is 32. So by simplifying this, what we will get, in the sense alpha value we will get. So degree of dissociation we are getting, that is 0.3408. Okay, degree of dissociation is how much, in the sense 0.3408 we will say. Next sum we will take. At 273 Kelvin and 1 atmosphere, at 273 Kelvin and 1 atmosphere, a liter of N2O4, a liter of N2O4 decomposes to NO2, decomposes to NO2, decomposes to NO2 according to equation, according to equation, N2O4 gas, N2O4 gas gives 2NO2 gas, 2NO2 gas. To what extent as the decomposition proceeded, to what extent as the decomposition proceeded, to what extent as the decomposition proceeded when the original volume is, when the original volume is 25% less than 25% less than existing volume, 25% less than existing volume. Okay, now we will see that temperature given, temperature this and all given, what is the equation? You see that N2O4 decomposes to NO2. Sir, N2O4 decomposes to NO2. N2O4 decomposes to NO2. Okay. Now what they are asking in the sense, to what extent has the decomposition proceeded? That means a degree of dissociation they are asking. They are asking what in the sense degree of dissociation we can say. Sir, to what extent it is a decomposed means a degree of dissociation. Sir, initially how much we have to see? Initially how much we have to see? So initial moles we will see. Initial moles we will take it as 1 mole. But they have given A liters of N2O4 decomposes, they said. Therefore, initial N2O4 is how much in the sense A liters. Okay, A liters. Therefore, now we will take a moles is directly proportional to volume. We will take under similar conditions of temperature and pressure. Therefore, initial moles we will take it as A moles we will take. Okay, number of moles is directly proportional to volume we will take. Therefore, initial moles A moles we will take. So how much dissociating? How much dissociating means X moles we will take. We cannot say alpha. Why? Because if initial is 1 mole, then only we can say alpha. Otherwise, we cannot say alpha. Okay. So at equilibrium, how much will be there? We'll see. At equilibrium, A minus X moles will be there. Now, NO2 how much produced in the sense here stoichiometric coefficient is 2. Therefore, 2X moles we will say. Okay. Number of moles is set. Now we want what in the sense, to what extent decomposition proceeded in the sense a degree of dissociation they are asking. So alpha of N2O4, degree of dissociation of N2O4 equal to how much dissociated by what is the initial, that value we want. So we want a X by A we want. Okay, sir. So what is sorry, this one. Next, what is the other given data? We'll see other given data. Original volume is 25% less than existing volume. Sir, now we will take original volume. Original volume is how much means 75% of existing volume we can say. Original volume is 75% of existing volume we can say. Okay. So we are getting what in the sense original volume we are getting, that is 75% of existing volume we said, because they said original volume is 25% less than existing volume. Therefore, original volume is equal to 75% of existing volume. Okay, sir. What is original volume and what is existing volume? Sir, first what is existing volume? What is existing here? Equilibrium is existing. Therefore, existing volume means what? Equilibrium mixture volume. Therefore, existing volume means volume of equilibrium mixture. Volume of equilibrium mixture is called existing volume into 75%. Okay. What is original volume? Original volume means what we have taken initially, that is called original volume. What we have taken? A moles of N2O4 we have taken. That is called original volume. That means original volume is nothing but initial volume. Initial volume we can say. Then we know that volume is directly proportional to moles. Volume is directly proportional to moles. Therefore, we will take it is initial moles we will take into equal to initial moles is equal to 75% of volume of equilibrium mixture means number of moles of equilibrium mixture. Like this we will take number of moles of equilibrium mixture. Okay, number of moles of equilibrium mixture we will take. So initial moles how much in the sense, that is A. We are taking initially N2O4, that is in 75 by 100 into moles of equilibrium mixture. Equilibrium mixture moles is how much? N2O4 A minus X, NO2 2X, therefore A plus X. So moles of equilibrium mixture is what in the sense? A plus X we can say. From this we will say X in terms of A we can say. Therefore we can get X equal to, so from this what we are getting in the sense, we are getting X is equal to how much in the sense 0.33. We got X. Okay, this X let us substitute here. X is equal to 0.33A, by denominator A is there, therefore equal to 0.33. So 0.33 is called a degree of dissociation of N2O4. Degree of dissociation of N2O4 we can say. They are asking what is the extent? What is the extent of decomposition? What is the extent of decomposition means a degree of dissociation of N2O4. So degree of dissociation of N2O4 is how much? 0.33 we can say. Okay. So degree of dissociation of N2O4 we said that is 0.33. Let us go to next sum. Consider the reaction. Consider the reaction A gives B. Consider the reaction A gives B. The standard enthalpy of formation. The standard enthalpy of formation of A is equal to minus 24.27 minus 24.27, and that of B is equal to minus 25.44 minus 25.44 kilojoule per mole. Okay. Standard entropy is given. Standard entropy for A and B are 246.4 and 252.3 joule per Kelvin per mole respectively. What is the composition of equilibrium mixture at 298 Kelvin? So composition of equilibrium mixture at 298 Kelvin we have to find. Composition of equilibrium mixture at 298 Kelvin we have to find it. Sorry. So we want a equilibrium mixture composition we want at 298 Kelvin. Sorry. So what are the given data? We'll see. Now this is the reaction A gives B. For this reaction, what is given in the sense from this we can find delta H, from this we can find delta S, and we know temperature. So what and all we can find, we'll see. So standard enthalpy of reaction is equal to standard enthalpy of formation of B minus standard enthalpy of formation of A. Set. So we'll substitute standard enthalpy of formation of B, we'll substitute minus 25.44 kilojoule per mole minus standard enthalpy of formation of A, will substitute minus 24.27 kilojoule per mole. Okay. From this we are getting standard enthalpy of formation. Sorry, we are getting standard enthalpy of reaction. We are getting, that is how much in the sense minus 1.17 kilojoule. So we got a standard enthalpy of reaction we got. Okay. Then from these standard entropy values, what we can get in the sense standard entropy of reaction will get. Standard entropy of reaction is equal to standard entropy of B minus standard entropy of A. Sir, standard entropy of B is how much in the sense 252.3 minus standard entropy of A is 246.4. This on simplification we are getting how much in the sense 5.9 joule per Kelvin per mole. Okay, so and so we are getting. Sorry. Now we will see this, we will convert into, this is in a joule, it is that joule per Kelvin per mole is the delta RS naught. Okay. Temperature we know, the 298 Kelvin we know. Using this delta H and delta S, using delta H, delta S and the temperature, what we can find? Okay. Now the using delta H and delta S and temperature, what we can find in the sense of delta G, we can find delta G naught is equal to delta H naught minus T delta S naught. Okay. Now we will substitute delta H naught, we will substitute delta H naught is how much in the sense minus 1.17 kilojoule per mole minus T temperature is how much, means 298 Kelvin. Delta S is how much in the sense 5.9 into 10 to the power of minus 3 kilojoule per Kelvin per mole. Okay. So what are the units get cancelled? We will see what are the units getting cancelled. Here this per Kelvin, this Kelvin get cancelled. Here 5.9 we have written as 5.9 in 10 power minus 3 because joule we have converted into kilojoule. Now we are simplifying, we are getting delta G. Delta G naught we are getting, that is how much in the sense minus 2.93 kilojoule. Okay. So using the given data, we have calculated so and so. Now what we want? What we want means composition of equilibrium mixture we want. Sir, that means delta G naught and equilibrium mixture, is there any relation? We know delta G naught for this equilibrium mixture. For this equilibrium mixture, we know delta G naught. For equilibrium mixture, equilibrium and delta G naught, is there any relation? Delta G naught and equilibrium, is there any relation? You think it? Okay. Yes, it is there. Yes, there is a relation. What is the relation? Means delta G naught is equal to minus 2.303 RT log Kc. Delta G naught equal to minus 2.303 RT log Kc we are seeing. Okay. So we will substitute delta G naught. Delta G naught how much? In the sense minus 2.93 kilojoule per mole, that we have substituted equal to minus 2.303. Then R value will substitute. R value is how much? In the sense 8.314 into 10 to the power of minus 3 kilojoule per Kelvin per mole. Kilojoule per Kelvin per mole. Okay. 8.314 into 10 power minus 3 kilojoule per Kelvin per mole. Then temperature will substitute. Temperature is 298 Kelvin into log Kc. So what we can find in the sense equilibrium constant we can find. So equilibrium constant is how much? In the sense 3.26. Now we will write equilibrium constant expression. Equilibrium constant is equal to, right side we will write in the numerator, left side we will write in the denominator, that is equal to 3.26. Therefore, what is the composition of B and A at equilibrium? In the sense concentration of B is to A is equal to 3.26 is to 1. It is the composition of A and B at equilibrium, we can say. So at equilibrium, what is the composition? What is the composition of A and B? That we got it. Let us go for next sum. For ammonium bisulfide, for ammonium bisulfide solid, for ammonium bisulfide solid is in equilibrium with ammonia gas and H2S gas, ammonia gas and H2S gas. The observed pressure, the observed pressure, the observed pressure for reaction mixture in equilibrium, for reaction mixture, for reaction mixture in equilibrium, for reaction mixture in equilibrium is 1.12 atmosphere, is 1.12 atmosphere at 106 degrees Celsius. At 106 degrees Celsius. What is the value of Kp for the reaction? Kp is equal to how much they are asking. Okay. Now we will take the given equation. We will take, what is the given equation here? Ammonium bisulfide solid is in equilibrium with the ammonia gas plus H2S gas. Ammonia gas plus H2S gas. Okay. Now what they are asking for this, in the sense Kp they are asking, Kp is equal to, what is the formula in the sense? Kp equal to right side thing we will write in the numerator, that is partial pressure of ammonia into partial pressure of H2S. Left side thing we have to write in the denominator. Left side what is there? In the sense ammonium bisulfide solid is there. Solid in the sense it's a partial pressure, we have to take it as 1. Active mass we have to take it as 1. So solid means don't write it. Okay, ammonia and H2S are gas, that write it. Ammonia pressure you write and H2S pressure you write. Ammonium bisulfide pressure you don't write. Okay, ammonium bisulfide is solid, therefore we need not take that. Okay, so ammonium bisulfide we need not take. Okay, now we'll see here the observed pressure for reaction mixture. The observed pressure for reaction mixture in equilibrium is 1.12 atmosphere. What does it mean? It is called equilibrium pressure. Equilibrium pressure is 1.12 atmosphere. Sir. So at equilibrium, the pressure exerted by ammonia is P atmosphere will take. P atmosphere will take. Then what is the pressure exerted by H2S? Ammonia is exerting, P atmosphere will take. Pressure exerted by H2S will be same P atmosphere, one possibility, then P minus X, then P plus X, like this possibility is there, isn't it? H2S gas will exert what pressure? Same P atmosphere it will exert, or less than that or greater than that. Which possibility we have to take? Is there any clue? No clue is given. Then what we have to do? Which we have to take out of these three? Which we have to take pressure of H2S? Set. So now we will take a one possibility. We'll see we are taking initially ammonium bisulfide. So initially what we are taking in the sense ammonium bisulfide A moles we are taking. We are not taking any ammonia. We are not taking any ammonia. We are not taking H2S. We are not taking any H2S. We are taking initially only ammonium bisulfide. We are not taking ammonia or H2S. Set. How much dissociating? How much dissociating in the sense X moles of ammonium bisulfide dissociating. X moles of ammonium bisulfide dissociating means at equilibrium how much will be there means A minus X moles of ammonium bisulfide will be there. How much ammonia produces in the sense X moles of ammonia produces. How much H2S produces in the sense X moles of H2S produces. If you take initially only ammonium bisulfide, you are not taking ammonia or H2S. Only ammonium bisulfide if you take, this on dissociation, you will get like this. Sorry, how it will undergo dissociation? How it is undergoing dissociation to give ammonia and H2S we will see. Ammonium bisulfide we will write it as NH4 plus HS minus. Ammonium bisulfide we can write it as NH4 plus HS minus. NH4 plus how to write in the sense N we have written 4 hydrogens we are writing. We are writing 4 hydrogens and a plus charge we are giving to one of the hydrogen. Then nitrogen group valency we are seeing nitrogen comes under nitrogen comes under 5th A group. Therefore, this valency shell contains 5 electrons. That 5 electrons we have written. Hydrogen contains 1 electron each. H plus is not containing any electron. Now we will give the bonding. We will give here one bond. We will give here one bond. Here one bond. Here dative bond will give. H plus is contributing vacant orbital. Then we will write this one in the form of a normal covalent bond. Normal covalent bond, when you are writing, you have to give formal charges. You have to give. For nitrogen, what nitrogen is a donor, therefore plus 1 charge we are giving. Hydrogen is acceptor, therefore minus 1. Already plus 1 is there, therefore becomes 0. It is ammonium ion. Okay. Then we'll see bisulfide. We'll see bisulfide. We can write it as S and H. Hydrogen is having 1 electron. Sulfur comes under group number 6A. Therefore, this valence shell contains 6 electrons. That 6 electrons we are writing in the form of dots. And minus charge is there. Minus charge is with the sulfur. Therefore, due to minus charge, additional electron we are writing. Then we are giving a bond between H and S. It is called a bisulfide. It is called a HS minus is called a bisulfide, we can say. Now, what happens means this S minus, it is a contributing lone pair to this hydrogen. This bond pair is shifting. Therefore, this S is taking H and becomes H2S. This becomes ammonia. Therefore, ammonium bisulfide on decomposition gives ammonia and H2S, we can say. So, one ammonium bisulfide will give one ammonia and one H2S. Therefore, X moles of ammonium bisulfide will give X moles of ammonia and X moles of H2S. So, in this possibility, number of moles of ammonia and number of moles of H2S produced same. Therefore, pressure exerted by ammonia at equilibrium, pressure exerted by H2S at equilibrium will be same. Therefore, pressure exerted by ammonia is P atmosphere, means pressure exerted by H2S also P atmosphere. P minus X, P plus X we need not take as per this possibility. Okay. So as per this possibility, we have taken pressure of ammonia is P atmosphere, pressure of H2S is P atmosphere. Now, what is the pressure of equilibrium mixture? That we'll see. Now, equilibrium mixture pressure. Pressure exerted by equilibrium mixture is equal to pressure of ammonia at equilibrium plus pressure of H2S at equilibrium. Then pressure of ammonium bisulfide at equilibrium we need not take because it is solid. Therefore, it is equal to 2P, which is equal to what is given. You see 1.12 atmosphere is given. So we are substituting 1.12 atmosphere. So we know that this 2P value we know. Okay. So now next step we will see we want Kp. Kp equal to pressure of ammonia into pressure of H2S. Pressure of ammonia and pressure of H2S are equal. That is equal to P into P. Therefore equal to P square we can say. Now this P value will substitute from this, that is how much in the sense 1.12 by 2, okay, that is square. This gives Kp. So now we got Kp. Kp is how much in the sense 0.3136 atmosphere square. Okay, this is Kp we can say. Okay, let us go to next sum. Some say the some solid ammonium bisulfite, some solid ammonium bisulfite, is placed in flask, containing 0.5 atmosphere of ammonia, containing 0.5 atmosphere of ammonia, What would be pressures of ammonia? What would be pressures of ammonia? What would be pressures of ammonia? And H2S? What would be pressures of ammonia and H2S when equilibrium is reached? When equilibrium is reached. Okay. Given data is ammonium bisulfite solid is in equilibrium with ammonia gas and H2S gas. Here Kp is equal to 0.11. Kp is equal to 0.11. Okay. Kp is equal to 0.11 we can say. Sorry. Now here equilibrium is given, Kp is given. What is taken initially that we will see. What is taken initially means some solid ammonium bisulfite and 0.5 atmosphere ammonia is taken. Then the system is allowed to attain equilibrium. Okay. Sorry. So what we have to find? What is the pressure exerted by ammonia at equilibrium and H2S at equilibrium is the question. Sir. So given data we will take. So given equation is ammonium bisulfite solid gives ammonia gas and H2S gas. Okay. Initially what is taken? Means some A moles of ammonium bisulfite and 0.5 atmosphere of ammonia. 0.5 atmosphere of ammonia is taken. 0.5 atmosphere of ammonia is taken. H2S is not taken. Okay. So initially ammonium bisulfite how much taken in the sense A moles we have taken, and ammonia how much we have taken means 0.5 atmosphere. H2S we have not taken. Okay. Now system is allowed for attaining equilibrium. System is allowed for attaining equilibrium in the sense forward will take place or backward will take place. Sir, which we will take place we will see. To take place forward ammonium bisulfite is required, that is there. To take place backward what is required means ammonia and H2S. Ammonia is available but H2S is not taken. So initially what will happen? Forward only will start. Sir, so forward only taking place. So how much ammonium bisulfite is equally is dissociating till attaining equilibrium means X moles will take. Okay, X moles we are taking. So how much by ammonium bisulfite remaining at equilibrium in the sense A minus X moles. Due to dissociation of ammonium bisulfite X moles, how much ammonia is produced in the sense X moles of ammonia is produced. Initially 0.5 atmosphere of ammonia is taken. Initially 0.5 atmosphere of ammonia is there and X moles of ammonia is produced due to dissociation of ammonium bisulfite. Okay. So how much H2S produced in the sense X moles of H2S produced. Why X moles of H2S produced in the sense X moles of ammonium bisulfite is dissociated. Sir, now what is the pressure exerted by H2S at equilibrium means suppose P atmosphere will take. Pressure exerted by H2S is P atmosphere will take. That P atmosphere is exerted by X moles of H2S. Now ammonia will exert how much pressure in the sense initially 0.5 atmosphere is there. This X moles of ammonia will exert P atmosphere. Therefore, this ammonia totally how much means 0.5 plus P atmosphere. So what is the pressure of ammonia at equilibrium means 0.5 plus P atmosphere. Okay. So pressure of ammonia at equilibrium is 0.5 plus P atmosphere. What is the pressure of H2S means P atmosphere. Pressure of H2S is how much? P atmosphere we can say. So now we will go for a Kp. Kp is equal to what we can say. Right side we will write in the numerator, that is partial pressure of ammonia into partial pressure of H2S. Left side we will write in the denominator. Left side is solid, its active mass is 1, so we need not consider. Now we will substitute Kp. Kp is given 0.11. Partial pressure of ammonia is given 0.5 plus P. Partial pressure of H2S is given P. Partial pressure of H2S is how much in the sense P. Okay. On simplifying this one, what we will get in the sense P we will get. So P is equal to how much in the sense 0.1653 atmosphere. It is called a partial pressure of H2S. So now we have to find partial pressure of ammonia, that is equal to 0.5 plus P. So P value we are substituting, therefore we are getting partial pressure of ammonia we are getting. So partial pressure of ammonia is how much in the sense 0.6653 atmosphere, and the partial pressure of H2S is 0.1653 atmosphere. Okay. Okay, let us go to next sum. For the reaction, CO gas plus carbon monoxide gas plus 2 times hydrogen gas gives methanol, methanol in gas. Hydrogen is introduced into a hydrogen is introduced into a 5-liter flask at 327 degrees Celsius, containing 0.2 mole of containing 0.2 mole of CO gas and a catalyst till the pressure is 4.92 atmosphere. At this point 0.1 mole of methanol gas, 0.1 mole of methanol in gaseous state is formed. Calculate Kc and Kp. Okay. So here initially what you are taking, you see, you are taking hydrogen, 5-liter flask, temperature 0.2 mole of CO, catalyst. Due to catalyst, rate of reaction increases, rate of forward reaction increases, rate of backward reaction increases, position of equilibrium is attaining fast, but position of equilibrium is not affected. Okay. So hydrogen gas is introduced till the pressure is 4.92 atmosphere. That means what? This 4.92 atmosphere is 4.92 atmosphere is attained. Okay, till hydrogen gas is introduced till 4.92 atmosphere is introduced. That means system is attained what? Equilibrium. So at equilibrium, what is the pressure given? What is the temperature given? Volume is given.